I guess let's take a look at page 1 of our chapter 10 review with our circles. The part 1, all we're doing is we're identifying these different parts of the circle. So here we want to know the center. Well, the center is, well, it's going to be right here at the center. So our center is just point O. Okay? We want to know all the radii. Well, first we can see the segment OQ is a radius, right? But we need to remember that when you have a diameter, you have 2 radii. So you also have segment OL and segment ON. And I look around, and those are the only 3 that come from the center and go to the circumference. So we're done. Your diameter, as we already spoke, right here, that creates those 2 radii, segment LN. And you can reverse it and say segment NL as well. Don't forget. Your secant is going to slice through, okay? And we're going to have a line on this one, okay? So we're going to have a line. We need to figure out, I've got 2 lines. We need to figure out which one slices through the circle and slices a part of the circle off. And that's going to be line MN. Or line NM. Your tangent barely touches the circle. Tangent barely touches. So we have line NP. We want to name an interior point. There's only one point on the inside. You need to understand again. Point M, N, Q, L. Those are on the circle. Okay, as we should be remembering from when we discussed about our angles and the circles. Okay, these are on. So there's only one, and that's that point O, that center. 6 wants the point of tangency. Well, there's only one tangent, which was line NP right here, so there can only be one point of tangency. It's going to be that point that touches. So we have point N. And we want one exterior point, or an exterior point. Look at that. There's only one that's outside the circle, point P. So let's take a look at going through our tangents. I believe this was like 10.3. Actually, 10.3 was with this also. So we're looking at our different tangents. Number 9, we want to find the value of x. What we need to remember is when we have 2 tangents, tangent RS and tangent ST, and they share that same exterior point, they are congruent. I will tell you right now, this 21 is extra information. Okay, we don't need that 21. All we need are our 2 tangents. So when 2 things are congruent, we set them equal to each other. Okay, and then we go through. You should be able to pause it and solve for x now. We know how to set it up. And then go and see if we got it right. So we wind up with 3x is equal to 21. When we divide both sides, we find out that x is equal to 7. Okay. On problem number 10, we want to find the value of x. So what we need to remember here is right here we have a tangent. Okay, this value of 12, that is a tangent. It's going to touch right here at our radius. And we learned that when we have a tangent that meets with a radius of a circle, we have a 90-degree angle. So all we have here is A, B, and C, Pythagorean Theorem. So we're going to use it. And if you know your triples, this is a multiple of a triple. We have our A squared plus B squared equals C squared. So A x squared plus B 12 squared is equal to, across a 90-degree angle, C squared, which is 15 squared. So here we'll get x squared plus 144 is equal to 225. And then just continue on through. You should be able to do this one on your own by now. We've been doing Pythagorean Theorem since at least 7th or 8th grade. X squared is going to equal 81. Find our square root. We find out that x is equal to 9. This is a 3, 4, 5 triple. Multiple of the scale factor of 3. 3 times 3 gives me 9. 4 times 3 gives me 12. 5 times 3 gives me 15. 11. This is where we have a circle inscribed in a quadrilateral. So let's take a look at this. What we need to remember with this is we've got tangents all created. Actually, it doesn't even matter if it's a quadrilateral. Sorry about that. But when we have these tangents, we need to remember that these two parts are congruent. These two parts are congruent. These are going to be congruent. And these, oops, need 4 of them, will be congruent. So we want the perimeter of the quadrilateral. So all we have to do is add all these little parts together. Some students like to add these and get the side lengths, and that's perfectly fine. Some people just like to add all the numbers together. I know with my class, I'll show you what we did. Here, since these are congruent, this is 1. These are congruent. This is 2. These are congruent, giving me 4, and these giving me 3. So what I showed and I like to do, now if you want to add 1 plus 2 to get 3 for this side, go for it. What I usually do is I go like this. I say, okay, 2. I vote over here, 4. Here I've got 8. And over here I've got 6. So then all I have to do is add those 4 numbers together. 2 plus 4 plus 8 plus 6 will give me a total of my perimeter. It's going to equal 20. Important things to remember about our tangents. All right, a couple of things to start talking about here. Number 12 through 14, we're going to state here that AB is going to be a diameter and CD is tangent. So first, let's take a look at, okay, it doesn't matter what order you go in, but I see a radius and I see a tangent. And just like up here we talked about, when you have a radius and a tangent that meet in a circle, you're going to have a 90-degree angle here. Okay, that will help us. I think that one helps us. Let's take a look. Angle AOC. So we need AOC. And, well, we have algebra. Well, let's take a look, guys. If we take a look at angle AOC and COB, that diameter forms a linear pair. And we've learned a linear pair is going to be 180 degrees. So what we're doing here is we have to add these two together to equal 180. So we have 9x plus 18 plus 8x plus 9 all equals that 180, that linear pair. So let's see here. I've got variable here and a variable here, giving me 17x. And then I have my positive 18 constant and positive 9 constant, giving me a positive 27. Equals 180. Pause it. You got it from here. Solve for x at least, please. All on your own. Have confidence in yourself. You've got this. Now that you've done that, like I asked, right? We subtracted that 27, right? You did it all on your own. Then we have 17x is going to equal 153. When we divide both sides by that 17, which you already did because you're so smart, we're going to come up with x equals 9. So to find the measurement of AOC, number 12, I'm going to switch back to that color, AOC, number 12. We know that we have 9x plus 18, so we're going to take that 9, remove it, and replace it with x plus 18, giving us 81 plus 18, letting us know that that angle measurement is going to be 99 degrees. When we take a look at the measurement of angle BOC, so we're looking at BOC, I call it COB, doesn't matter as long as O is in the center. Okay, so number 13, we're going to take 8x plus 9, so we take 8, remove x, put in that 9 that x was, plus 9. We're going to wind up with 9 times 8 is 72 plus 9, giving us a total of 81 degrees. And if you look at it, 12 and 13 should add to 180. Well, 99 plus 81 is going to give you 180 degrees. The last one here is asking us for the measurement of angle OCD. So from O to C to D. O, knowing that tangent and radius are perpendicular, did help us out. This is just 90 degrees. All right, there's page 1.